Hello friends, in this video, we will talk about the multi-object tracker for the autonomous vehicles. The multi-object tracker establishes a correspondence between the detections received and pre-existing tracks surrounding the autonomous vehicles. Generally, when it comes to tracking, at that time we need to consider the unknown number of non-ego vehicles surrounding the ego car, and that too for the varying period. This problem of correspondence has to be solved, as we cannot tell which detections are from vehicles that had been detected earlier, which detection is from object birth, and which are from the clutter. Recently, this problem has been solved with the help of random finite sets, and beautiful mathematics is used to define the environment surrounding the ego vehicle. In the case of the multi-object tracker, it considers the model for the measurements coming from the objects in clutter, a model for the motion of the vehicles, and the model for the prior state variables of the non-ego vehicles. In the latest research, states and the number of vehicles are represented using random finite sets. At each time step, the total number of tracks available is the sum of surviving tracks from the previous time step, which are generally modeled as multi-Bernoulli random finite set with a certain probability of survival to account for the missed detections, and object births at current time instant, which is modeled as Poisson point process RFS with certain clutter intensity to account for the false object detections. The different trackers that are used in the industry are: 1. GNN, Global Nearest Neighbor, Tracker. 2. JPDA, Joint Probability Data Association, Tracker. 3. MHT, Multi-Hypothesis Tracker, Tracker. 4. PHD, Probability Hypothesis Density, Tracker. The performance of these trackers is assessed using GOSPA, Generalized Optimal Subpattern Assignment. Generally, the steps for the sensor fusion and tracking to get the most accurate tracks in the environment are as follows. 1. Sensor data preprocessing from various sensors. 2. Correspondence metric creation and Hungarian algorithm, or use some multi-object tracker to handle the correspondence and object birth as well as death. 3. Kalman update and prediction step. That's all for this video. To learn more about the state estimation filters and multi-object tracker, do subscribe to my channel.